equation of the experiment. This is potassium iodide, lead nitrate, and then it becomes a lead iodide and potassium nitrate.
Our materials we used were distilled water to mix it with potassium iodide and lead nitrate to make it a solution. And we used a heater to heat it up so it can dissolve and then we can see the reaction.
Okay, here's the procedure. We're going to be doing the experiment. Okay, first we need to create an aqueous solution of potassium iodide and pour it into a round flask.
That's why we use the distilled water to mix it with the potassium iodide and the lead nitrate.
Okay, so here's the potassium iodide.
And then in this one we put the lead nitrate.
And then in this we have to mix them. Then we need to put both in one single beaker.
You'll see how it changes color.
Gold rain.
That's not the gold ingredient.
So that reaction happened.
Wait, let me disconnect. Okay, once you have this, it says that you need to hit the mixture and wait for the precipitate to dissolve. It's gonna be heating down here because it cannot reach the table.
Do you want gloves to wear?
No, because right now we're not gonna be picking it up yet. We need.
Like,
Okay, but it's not gonna be splashing out or anything like that?
No,
The
no.
lead nitrate, okay, because the lead, if it gets on your hands, it's not bad.
No, it's not. It doesn't splash.
They know their stuff, Mr. Costa.
No, I know, but I'm just saying, like, well, if you get lead on your hands, it actually soaks.
Okay,
But it's not
here's
good.
kind of because this was for our stoichiometry unit, and here is the process in which we had to figure out how many moles of each reactant were utilized. Our calculations resulted in 0.27 moles of potassium iodide and 0.012 moles of lead nitrate.
We had to calculate how many moles of each product should be formed, and we calculated that lead iodide should be 0.135 moles, and potassium nitrate should be 0.027 moles.
And then the amount of grams that each product forms at the end of the experiment is 6.22 grams, the lead iodide, and the potassium nitrate is 2.727 grams. Okay, here are some of the descriptions of our experiment. The type of reaction is it's an ionic reaction, and it's obviously a chemical reaction. The chemicals involved in the reaction are the ones that we showed at first, the ones in the valence equation that you saw, the lead nitrate and the potassium and iodide. And potassium iodide is actually a polar covalent, and then the lead nitrate is ionic.
The percentage composition.
Do any of you know what percentage composition is? No. Well, basically, the percentage composition is how much of each element is present in a compound, and we used lead nitrate.
We had 63%
Of lead,
8% of nitrogen, and 29% of oxygen.
yeah, and it is an endothermic reaction.
It takes a lot of
It
time.
takes a long time. So here's a time lapse of what should occur.
We have. It starts to boil,
You can see it boiling there.
and after like 30 minutes to an hour,
Nalagay sa pagkanto, sa mulo.
the substance dissolves and then becomes like
Let me show
if
you
it was
one.
water. And when you cool it off,
Okay, here's like it's kind of boiling. You can see how it started. Like
it starts to boil.
it's starts to boil, and once it heats up, you need to set it so that it can cool down, and then it becomes this sparkly substance.
That
When you shake it, then
Golden
it's,
ring.
golden ring.
then it sparkles.
It's like glitter. And then after that, you put that on.
Any questions, you guys?
No.
Be rude, Isabel.
Do you have any questions?
You want me to ask a question?
No, it's okay.
Can you pass out the?
Why don't we do this last?
Well, okay, I've got a question. Why do you say potassium iodide is polar covalent?
Why we say that?
Yeah, why do you say that potassium iodide is polar covalent?
Okay, when you look for it, when you look for
You
it,
can mix it,
when you look
see
for
how
the
it
periodic
mixes,
table,
but then it.
Pb, K is potassium. We looked at the electronegativities of potassium and iodine. Then we need to subtract each, like the highest one from the lowest one, and then look at the chart of polarity. We look at the chart and we see where it falls into. It falls into in the polar one, and since it's a covalent compound, we know that it's.
So the electronegativity difference was low enough to consider it polar covalent. Good job, good explanation.
Great job.
Very entertaining.
Okay, go on.